this video, I'm going to show you how to use the linear models function, or the LM function in R, to find the equation of a regression line for a data set. To do this, we need to have some kind of a data set, which I've already loaded up here, a data set I called DAT. And if you take a look at it, it's got 11 pairs of data values. There's an X variable and there's a Y variable. And I'm going to go ahead and try to find an equation of a regression line for it. And before you ever do that, you always want to take a peek at your data and see what it looks like, see if it's worth asking for a regression line there. And so in this case, I'm going to plot the data. So I'll use my plot command, and then I'll just type in DAT. So I'm going to plot DAT. And you'll see over here, I've got my X variable on the horizontal, Y on the vertical. And these points do appear to be following some kind of a linear trend. So it does seem to be reasonable to ask what would be an equation of a regression line here. So to find this equation, what I'd do is I'd want to make up a variable to store some results in. So I'll call this fit, and then you'll use this linear models command, or this linear models function, I should say. And then what you have to give it, well, there's several things you can give it. We're just going to worry about two things here. So you'd have to give it a formula for it to base its equation on. So I'm going to say I want to have y be a dependent variable, and y is dependent upon x, or y is a function of x. And in this particular case, since it's inside this LM function overall, we're saying that y is a linear function of x. And then you'd have to tell it where your data lives. And my data lives in the data frame called DAT. And so I can go ahead and run this, and you don't really see anything happen other than you get a new variable loaded up over here that happens to be a list of 12 items. And if you want to get a decent idea of what's sitting inside there in terms of the list without looking at it, you'd use this summary command. And if you run this, it will give you back a nice long sort of printout here. And it'll tell you that you're using a linear model based upon y being a function of x. It'll give you some information about some things called residuals, which we won't worry about for now. It will also give you a bunch of printouts about the results of some kind of hypothesis tests. Again, those we won't worry about here, and that's exactly what some of these values right here are. These are telling you something about estimates for errors, and these are telling you about some hypothesis tests right here. What we're really interested in right now is just the estimates for an equation of a regression line. And so we can see here there's a slope, and we can see here there's an intercept. And so that would be the slope and the intercept of the regression line you're looking for. Now, if you actually were trying to pull those values out of there, what's nice is there's a little command called coefficients, and then you just throw in your fit value there. And what will happen if you run that, it will actually pull out of that result, that list fit, the intercept and the slope. And what can you do with those? Well, you might want to actually graph that regression line equation. And the way you can do that is you can use the AB line function. And then if you remember, its arguments have to be the intercept and then the slope. So I can, if I want to, just put the coefficients of fit inside there and run that. And that will plot for me the equation of a regression line on top of those points that I've already plotted there. And indeed, it looks like it's running through them. So that's how you can use the linear models command to find the equation of a regression line.